If you have ever asked a large language model for JSON and then written brittle regex to clean up the response, this build is for you. Today we wire Azure OpenAI together with Pydantic in Python to get outputs that are guaranteed to match your schema every single call. By the end, you will be able to define a typed model, pass it straight into the parse call, and pull a validated Python object back out. We will cover the prerequisites, the exact client code, what happens under the hood, and what to verify when it is working. Let us build it end to end. First, why bother? The old approach is to beg the model in the prompt to return JSON, then hope. You still hit trailing commas, markdown fences, hallucinated fields, and the occasional apology paragraph wrapped around your data. Structured outputs flip this. You hand the service a JSON schema derived from your Pydantic model, and the decoder is constrained so it can only emit tokens that keep the output valid against that schema. That means required fields are always present, enums stay in range, and types are correct. You trade a tiny bit of flexibility for determinism in shape, which is exactly what you want when the output feeds a downstream system. Here is the architecture. Your Python application holds a Pydantic model that describes the response you want. It calls a deployed model on your Azure OpenAI resource, passing that model as the response format. Azure OpenAI returns a JSON payload that conforms to the schema, and the SDK parses it back into an instance of your Pydantic class. Secrets like the endpoint key live in Key Vault, or better, you use Microsoft Entra Managed Identity, so there is no key at all. Nothing exotic here, but the discipline is that the schema is the contract between your app and the model. Before any code, 3 setup steps. 1. In the Azure portal or with the CLI, deploy a model that supports structured outputs. At recording time, that means a recent GPT-4o snapshot. For example, the 2024-08-06 version or newer. 2. Note your endpoint and pick an API version that supports the parse feature, such as 2024-10-21 or later. 3. Grant your identity the Cognitive Services OpenAI user role so managed identity works. Model and version support changes fast, so check the current Azure docs for the exact snapshot and API version that supports structured outputs. Now the payoff. You define your shape as a normal Pydantic model with typed fields. Then instead of the usual create call, you use the beta.chat.completions.parse method and pass the class itself as the response format. The SDK converts your model to a strict JSON schema, sends it, and gives you back a parsed attribute that is already an instance of your class. No json.loads, no try except around malformed text. Notice we use Azure Managed Identity here through a token provider rather than a raw key. From this point, your invoice object is just a typed Python object you can pass downstream. Understanding the layers helps you debug. At the bottom, your Pydantic class is serialized to a strict JSON schema, with additional properties disabled and every field marked required. That schema is sent with the request. The service uses constrained decoding, so at each step the model can only sample tokens that keep the emerging JSON valid against the schema. The raw JSON comes back, and finally the SDK validates and hydrates it into your Pydantic instance. One caveat worth knowing: strict mode does not support every JSON schema feature, so some advanced validators or unusual types may be rejected. Keep your models reasonably flat and you will avoid surprises. How do you know it is healthy and not silently failing? First, assert that message.parsed is not none, because a content filter or a length cutoff can leave it empty. Check the finish reason. If it is length, the model ran out of tokens mid-object, so raise your max tokens. Inspect the refusal field, which is populated when the model declines for safety reasons rather than returning malformed data. Log token usage to watch cost, since strict schemas can add overhead. And write a test that feeds messy input and confirms you still get a clean, typed object back. Those 4 checks catch almost every real-world failure. To recap, deploy a supporting GPT-4o model. In a recent API version, define your Pydantic schema. Call beta.chat.completions.parse with the class as the response format, and read the parsed object. The schema becomes the contract. Constrained decoding enforces it, and the SDK hands you a validated object. Your one concrete takeaway. Take any place in your code where you currently call json.loads on a model response, and replace it with a Pydantic model and the parse method. You will delete a pile of defensive parsing code today. And because model and API support shifts often, confirm the current snapshot and version in the Azure docs before you ship. If this helped, do me a favor. Hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.